This is video number 2 for section 2.1. I just want to talk a little bit about when a derivative does not exist, like what's happening when that occurs. Okay, so when a derivative doesn't exist, there are two things that can happen. One is you have a sharp turn in your graph at that point. So if there's a sharp turn, like in this graph right here, there's a derivative. The derivative does not exist at this point. It doesn't exist at 2, and I'll explain why in a minute. Also, when you have a cusp or you're going to have the tangent line to the graph is going to be vertical. Now we know what is the slope of a vertical line. Are you all saying it's undefined? Yes, you are. Great. So when you have an undefined slope, that is when a derivative does not exist as well. So anytime you have a vertical slope, the derivative does not exist, or if you've got a sharp turn in the graph. So I'm going to explain the sharp turn, why the sharp turn is not working, and then there in the packet that I gave you with the keyed notes, there is an explanation of this one, so you can take a look at that. So what is happening when we have this sharp turn? Let's think about this. We have to find the limit at point C. That's what we're looking for. We're looking at the limit at point C as x approaches C, okay? So what's happening is this distance right here, as x gets closer to C, obviously, think of as C is 2 and x is getting closer to 2, that means this subtraction, this distance is getting smaller and smaller and smaller, okay? It's shrinking this distance right here. So when you find the limit of this, of a function like this one, okay, now remember these absolute value functions, they're a little funky. What you need to do is you need to find the limit from one direction, the limit from the left and the limit from the right, and those limits have to be the same. So what we're going to take a look at here is if I take the limit, I'm going to get this function. Let me just set up this function first of all. So f of x minus f of 2 over x minus 2. So f of x minus f of 2, because my c is 2 in this case, okay, divided by x minus 2, okay? So that's what we're going to be doing here. So my function is x minus 2, absolute value of x minus 2. So what I basically have here is the absolute value of x minus 2 minus 0, because the f of 2 is 0, okay? Correct? If I plug in a 2 here, I get 2 minus 2, which is 0. So this is 0, divided by x minus 2. Okay? So essentially what I have to do is find the limit as x approaches 2 from the right of the absolute value minus, x minus 2, absolute value of x minus 2 divided by x minus 2. And then also find that limit from the left. Okay, and if those limits are the same, then the limit exists and we can move on. But we're going to discover something weird. You might remember what this graph looks like and what happens with the limits with it. So to make this a little bit easier to understand, I'm going to take us over here to the graph of it. So this is the graph of the absolute value of x minus 2 divided by x minus 2. Basically, when x is greater than 2, your y is always going to be 1. When x is less than 2, it's always going to be negative 1. X can never be 2, okay? So think about the guy walking along the path to the party, okay? If you're coming from the left, your limit is negative 1. If you're coming from the right, your limit is positive 1. Those do not meet. If you are heading to the party from those directions, you are not getting to the same party. So the limit does not exist. So this limit is different than this limit. This limit is coming from the right was 1, coming from the left was negative 1. So the limit does not exist. Oops. And since the limit does not exist, this limit does not exist, it's not differentiable at C. It's not differentiable at 2. It's differentiable at other points, but it's not differentiable at 2. Okay? So whenever you have a sharp turn in your graph, it's not differentiable at that point. Whenever you have a vertical tangent line on your graph, it's not differentiable as well.